Magandang umaga po sa inyong lahat. Ako po si Jamsi Perez ng DOST-PCAARRD. Pag-uusapan natin ngayong umaga ang ilan sa mga natatanging teknolohiyang itinampok ng DOST-PCAARRD sa National Science and Technology Week. Binabati namin ang ating participants na mula sa mga state universities and colleges, government agencies, at private companies mula sa Luzon, Visayas, at Mindanao. Salamat po sa inyong pagdalo. I-remind lang din namin ang participants na magbibigay kami ng e-certificate pagkatapos ng webinar na ito. Abangan ang link ng Customer Satisfaction Feedback o CSF form sa huling bahagi ng ating webinar upang masiguro ang inyong e-certificate. Hinihikayat rin po namin ang lahat na i-share ang ating live webinar sa ating mga FB wall upang mas marami pa po ang makapanood at makasama natin sa live webinar na ito. Tatalakayin natin ngayong umaga ang 5 paksa. Una, ang test kit para sa pag-detect ng African Swine Fever o ASF virus. Pangalawa, ang itlog na maalat na may mas mahabang shelf life. Pangatlo, ang teknolohiyang seaweed farming para sa mga komunidad ng Palawan. Pang-apat, ang BANDALA fibers for textile production. At ang ikalima, ang Enriched Potting Preparation o EPP para sa urban container gardening. Excited na ba kayo para sa mga detalye sa mga nasabing paksa? Pero bago ang lahat, pakinggan muna natin ang buod ng GALING-PCAARRD kontra COVID-19 program mula sa aming Executive Director, Dr. Reynaldo V. Ebora. Pakinggan natin ang kanyang mensahe.
Magandang araw po sa ating lahat. Marami sa ating mga kababayan ang lubhang naapektuhan ng pandemyang dulot ng COVID-19. Malaki ang naging epekto nito sa iba't ibang aspeto ng ating buhay, pati na rin sa ekonomiya ng bansa at ng buong mundo. Marami ang nawalan ng trabaho dahil sa limitadong paggalaw at pagbabawal sa paglalakbay bilang bahagi ng quarantine. Ipinatutupad ito ng ating pamahalaan upang maiwasan ang pagkalat ng COVID-19 sa ating mga pamayanan. Dahil sa pagkawala ng trabaho at hanap buhay, marami sa ating mga kababayan ang nakaranas ng gutom at kawalan ng pag-asa. Pagkain ang pangunahing pangangailangan ng mga Pilipino. Bilang ahensya ng gobyerno na tumututok sa pagsasaliksik ng mga makabagong paraan upang mapataas ang produksyon at kalidad ng pagkain, bahagi ng responsibilidad ng DOST-PCAARRD ang makatulong sa ating sambayanan ngayong panahon ng pandemya. Kaya naman, inilunsad ng DOST-PCAARRD ang Good Agri-Aqua Livelihood Initiative Towards National Goals o GALING-PCAARRD kontra COVID-19 program. Ang programang ito ay aming tugon sa mga suliraning kaakibat ng pandemya na may kinalaman sa supply ng pagkain at hanap buhay na nakabase sa agrikultura at pangisdaan. Ito rin ang aming suporta sa bayanihan to heal as one act. Inilunsad ang programa ilang linggo matapos ipatupad ng Enhanced Community Quarantine o ECQ noong Marso. May 3 bahagi ang programang GALING-PCAARRD. Ito ay ang mga sumusunod. Una, teknolohiya kaalaman para sa pamayanan. Pangalawa, lingkod alalay sa pamayanan. At pangatlo, pagkain at kabuhayan sa pamayanan. Layunin ng teknolohiya at kaalaman para sa pamayanan ang magbahagi ng mga teknolohiya at kaalaman tungkol sa sektor ng agrikultura, pangisdaan, aquatica at likas na yaman sa pamamagitan ng mga babasahin at publication na ipinamamahagi sa pamamagitan ng aming e-library at social media. Samantala, sa lingkod alalay sa pamayanan ay nakapagbigay ng mga proyektong karamihan ay pagkain sa iba't ibang parte ng bansa. Ito ay sinagawa noong panahon na pinatutupad ng ECQ at modified ECQ na kung saan hindi pa malayang nakalalabas sa mga tao sa kanilang mga tahanan. Ang pangatlong bahagi ang pagkain at kabuhayan sa pamayanan. Layunin ito na magsulong ng mga proyekto sa produksyon ng pagkain na maaari ding mapagkakitaan ng ating mga kapwa Pilipino. Hindi namin matagumpay na may sasagawa ang lahat ng aktibidad ng GALING-PCAARRD kung hindi sa tulong ng aming mga katuwang sa bawat rehiyon ng Pilipinas, ang aming 15 regional consortia at ang mga ahensyang kasapi nito, kabilang ang mga DOST regional officers. Ang GALING-PCAARRD kontra COVID-19 program ay patuloy ang pagtulong sa ating mga kababayan upang sama-sama tayong bumangon mula sa mga suliraning dala ng pandemya. Sa pamamagitan ng pagtutulungan at pagkakaisa ng lahat, nakatitiyak tayo na malalampasan natin ang hamong ito. Maraming salamat po.
Maraming salamat, Dr. Ebora. Tunay nga marami ang natutulungan at matutulungan pa ng programang Galing-PCAARRD kontra COVID-19 program. Ang una nating speaker pala ay si Dr. Clarice Yvonne J. Domingo, o Dr. Cla, Professor sa College of Veterinary Science and Medicine ng Central Luzon State University, Science City of Muñoz, Nueva Ecija. Alamin na natin ang detalye ng kanilang pag-aaral at binuong nano-gold test kit for African Swine Fever virus.
Good morning to everyone. Today, I would like to present to you a test kit we developed that combines the LAMP principle and nanotechnology. It is called NanoGold Biosensor Test Kit for African Swine Fever virus. African swine fever is a hemorrhagic disease of domestic swine that limits the development of the pig industry in countries within which the disease is endemic. Due to the lack of an effective vaccine, options for control are limited to quarantine and slaughter of pigs on infected farms. The map shows the provinces with different colors, and those in red indicates the infected zone confirmed by real-time PCR. Yellow indicates the surveillance zone that is high risk. The pink indicates the buffer zone, which is adjacent to the red. The light green is the protected zone with no ASF and is low risk. And lastly, the dark green is the area which remains ASF free. ASF is a transboundary animal disease and is spread by live or dead pigs, domestic or wild, and pork products. Also via contaminated feed and fomites, which are non living objects such as shoes, clothes, vehicles, knives, equipment, water, and soil, due to the high environmental resistance of ASF virus. There is no approved vaccine against ASF, unlike classical swine fever or hog cholera, which is caused by a different virus. In the Philippines, the first case in 2019 was confirmed by the Pierbright Institute of UK using real-time PCR. The virus is a large DNA virus of the Asfar viridae family, and this virus has a double-stranded DNA genome varying between 170 and 190 kilobase pairs in length. The virus protein P72 is the major antigenic capsid protein that makes up about 32% of the total protein mass of the virion and is antigenically stable. So this is the one that we used as target gene in our test kit. From time to time, however, reports of depleted test kits for real-time PCR for surveillance cause massive delay of results that affect the establishment of the zoning areas. So therefore, there is a need for more affordable, portable, rapid, but sensitive test assays as an alternative to what is currently being used. So our test kit can detect ASF virus or its genetic material from surface swabs of inanimate objects in farms and delivery trucks, water that supplies the farm, infected body fluids such as blood and saliva or oropharyngeal mucosa, and feces. Also, from raw, processed, or canned pork products. So, one test kit can hold uh, reagents that are good for 10 samples, but pooling of 3 samples is allowed. So it contains consumables such as the microcentrifuge tubes, mini droppers, tuberculin syringes that replace the pipetors in the laboratory, canisters that hold the lysis buffer, extraction buffer, wash buffers 1 and 2, and the rehydrating buffer, and also rubber floaters. Likewise, um, it also comes with a cooling bag or a styro box that holds 3 frozen gel coolants, PCR tubes that contain the nanogold premixes, and PCR tubes that contain the gold dye. Samples can be tested are whole blood samples that should uh, have anticoagulants to prevent the clotting, because we do not need the serum here. We need the macrophages intact. And then water samples, of course, rectal swab for fecal samples, oro- for oropharyngeal swabs for saliva or samples in the mouth, and then surface swabs that were collected from the walls, the floors, the nipple drinkers, and also surfaces from the delivery trucks and even pigways. Also, we can use homogenates or the juice from fresh, frozen, or processed pork. Now, this slide shows a simple diagram of how the test kit works. Basically, it is a combination of lamp primers that amplify the P72 target gene of the ASF virus. There are 3 pairs of primers that were designed based on the whole length of the P72 from the 194,640 base pairs length of the whole genome of the ASF virus, which is a Pinoy strain from the blood sample taken in Plaridel, Bulacan last September 2019. The test kit has a built-in DNA extraction process where the sample will undergo lysis phase, extraction phase, and the wash buffer phase. All these phases shall require the microcentrifuge to mix well. Finally, the tubes will undergo drying and rehydration. The entire duration will take 1 hour and 30 minutes for 10 samples, whether individuals or pooled by threes. The DNA isolate after that will be added to the nanogold premix, which contains the primers and the enzyme mix. The tube shall be placed in a heat block at 58 degrees centigrade for 30 minutes, after which the gold dye shall be placed to the amplified sample. Upon contact with the amplified samples, the gold dye will immediately change its color. If the dye retains its original color, which is wine red or any intensity of red, then the sample is interpreted as negative for ASF. If the dye turns to gray or to any intensity of gray to violet gray, then the sample is read as positive for ASF. In the development of the test kit, we've observed that it can indirectly qualify the viral load of the sample by means of the intensity of gray. The grayer color, the higher the viral load. in the sample, while the more violet, the fewer the load. Yet both are read as positive. So the ESF Nano Gold biosensor is very affordable. The price of one kit is 3,500 pesos, which can test 10 samples. The test kit can be done on individual samples or on pooled sample of threes for blood and meat homogenates, and on pooled sample of fives for surface swabs, fecal swabs, and for saliva or oropharyngeal swabs. So in my next, or rather my last slide, I would like to thank you for your attention. And further, I would like to acknowledge Father God Almighty, who is our source of wisdom throughout the entire test kit development, the Blitzkrieg R&D team, the funding agencies, which are the Department of Agriculture, Bureau of Animal Industry, and the DOST Picard, and the molecular laboratory of the College of Veterinary Science and Medicine of the Central Luzon State University. Thank you very much.
Maraming salamat Dr. Domingo sa pagbahagi ng detalye tungkol sa mura, mabilis at epektibong test kit upang matukoy ang ASF virus. Para sa ibang may katanungan kay Dr. Domingo, maaari ninyo itong i-comment upang masagot niya ito mamaya sa open forum. Ang unang yugto ng open forum ay magaganap pagkatapos ng ating ikalawang tagapagsalita. Pero muli, ay hinihikayat po namin ang ating mga viewers na i-share ang ating live streaming upang mas marami pa ang makapanood ng ating talakayan. Ang ating susunod na tagapagsalita ay si Dr. Lotis E. Mopera, Director at Associate Professor sa Institute of Food Science and Technology, College of Agriculture and Food Science ng University of the Philippines, Los Baños. Let us all welcome Dr. Mopera.
Good morning. Today, we would like to present a portion of our study under the project Duck, Eggs, and Meat Processing Innovation under the program Eating for Life, funded by the DOST card. Considered the second largest poultry industry in the Philippines, the duck industry is one of the most versatile in terms of commercial significance, solely depending on meat and eggs. One of the most important secondary products of the duck industry is the production of salted duck egg. Because of its affordability, ease of production, popularity, and variety of uses. Salting also improves the flavor, texture, and storage properties of the eggs. Salting is only a way of preserving the eggs and does not absolutely retard the growth of microorganisms. Duck eggs are preferred over chicken eggs in terms of salted egg production because of the relatively thicker eggshell as well as its more desirable characteristics after the salting process. Several studies have been done with regard to the different approaches of salting process and extension of shelf life of salted duck eggs. The salting medium or clay salt solution have been identified as possible sources of microbial contamination during the salting process. Factors that may cause spoilage, like microbial contamination, moisture loss, gas exchange, and post-process handling, are not addressed by these studies. Edible film coating application have been proven to extend the shelf life of several food products by preventing the microbial contamination and oxidation, specifically in fresh fruit and meat. Also, such application can prevent moisture and flavor loss and slight physical deterioration during storage. Considering that the eggshell is the point of entry of microorganisms, as well as gas exchange and moisture loss that can cause spoilage and deterioration in salted duck eggs, it is possible that films or coatings can possibly address the problem on quality deterioration and short shelf life of salted duck eggs. Further, incorporating an antimicrobial agent in the film will help prevent microbial contamination of salted duck eggs after the salting process or during storage. Antimicrobial coating can extend the shelf life of salted duck eggs by preventing post-process microbial contamination and moisture loss. The preservation method of salted duck eggs, wherein the surface of the salted duck eggs are coated with a layer of safe and non-toxic fresh-keeping material, was applied. This coating can reduce the water loss rate of the salted duck eggs. The taste can be improved and prolong the shelf life. Special film preservative or cooked salted duck egg with barrier performance, antimicrobial properties, and mechanical properties was also studied. They use a film former, a hydrophobic agent, and a surfactant and a solvent. In a related study, which focus on the physical properties of sorbate-containing tapioca starch glycerol edible films as affected by gelatinization and drying process, the study used mixtures of tapioca starch, glycerol, and water, or of starch, glycerol, potassium sorbate, and water. The two foams with the different formulations were prepared using the three different methods at different ratios or concentration. In our particular study, we explored a combination of cassava starch, glycerol, water, and an antimicrobial agent with GRAS, or generally regarded as safe status, called potassium sorbate. It is commonly used as a preservative in the food industry. We explored the possibility of forming a film coating to extend the shelf life of salted duck eggs. To extend the shelf life of the eggs, the presence of potassium sorbate as an antimicrobial agent on the film possibly aided in minimizing the contact and slowing the growth of halophiles in the egg, which is supported by the findings in one of the studies, wherein the addition of salt sorbate to the salt used during salting of food products can successfully combat the halophilic bacteria and molds that causes the red discoloration on the salted food. Halophiles are also known to cause spoilage in salted duck eggs. In the utility model filed as IPOFIL, as part of the products of this study, cassava starch and potassium sorbate is expected to prevent the post-process microbial contamination and moisture loss by blocking the microorganisms from entering the eggshell pores and therefore preventing the exchange of gases that could lead to quality deterioration. The pores of the eggshell are possible sites for microbial access, and the exchange of gas can cause spoilage. The cassava starch potassium sorbate coating provides a good barrier against these agents. The application of coating is considered a practical solution or application that can extend the shelf life of salted duck egg stored at ambient temperature. Normally, salted duck eggs usually last for only 3 to 4 weeks, but in this study, we were able to extend the microbial shelf life of the coated eggs from 5 weeks to 12 weeks. As a matter of fact, even at the end of the 12-week period, it still complies with the microbial count requirement in terms of aerobic plate count. The antimicrobial coating that we applied in the salted eggs is composed of cassava starch at 4 to 6%, glycerol at 1 to 3%, distilled water at 90 to 95%, and potassium sorbate at 0.1 to 0.5%. The film is produced by making a solution of cassava starch, glycerol, and water. The solution or the mixture is heated up to 70 degrees Celsius in order to facilitate the gelatinization of the starch. After which, the solution should be cooled down to at least 60 degrees Celsius before adding the potassium sorbate to prevent the sublimation of the preservative or the antimicrobial agent. After which, the salted egg should be soaked into that particular mixture, making sure that all of the entire surface of the egg is coated with the film coating as such. And it should be dry in the oven at 50 degrees for at least 2 hours. Physical inspection should be done to ensure the continuity of the coating on the eggshell, and you have to make sure that no cracks or leaks are present in the eggshell itself. This is the photograph of the coated salted duck eggs. The picture underneath are the coated eggs, and you can see that there is a defined shiny feature for the coated eggs using the cassava starch potassium sorbate film. So I guess the next question is, how cheap is it to produce this particular coating? Based on our estimate, at least 500 ml coating can coat up to 350 eggs at the rate of 1.5 ml coat per egg, and for a cost of 100 eggs, the producer will only spend about 5 pesos and 65 centavos based on the current price of the different raw materials used for the coating. The technology is expected to increase the income of salted egg producers by 2 to 4 times because of the extended shelf life. The extended shelf life will also provide opportunities for the salted eggs to be sold overseas with the extension in its shelf life, provided, of course, that packaging technologies and logistic requirements are complied with. With this, we thank the OSTP card and GIA for the funding, and thank you very much for listening.
Bago tayo magtungo sa unang open forum, nais naming batiin ang mahigit sa 200 participants na nanonood ngayon sa ating webinar. Sa puntong ito, ay tatanggap tayo ng mga katanungan mula sa ating mga participants at tagapakinig mula sa ating FB live stream. Aming tatawagin muli sina Dr. Domingo at Dr. Mopera upang sagutin ang inyong mga katanungan. Hello po, Dr. Domingo, Dr. Mapera.
Hello.
Hello po, ayun po. May ilang mga tanong tayo natanggap mula sa ating registration form. Ang mga ito ay pinagsama-sama namin mula sa mga katanungan na sinend sa atin ng mga registrants. Ang unang katanungan ay para kay Dr. Domingo. Is the test kit 100% effective in detecting ASF? Is there a vaccine for ASF? And can ASF be treated? Mula kay Ms. Bel Sorara ng Eagle Broadcasting Corporation.
Okay, so yung una, is it 100% effective? Alam ba ninyo, ang walang test kit na 100% effective. Meron at merong marginal na error na pwedeng allowed. Okay, so ang supposedly, if it's a novel test, bagong gawa, bagong develop, ang acceptable is above 85% na sensitivity or effectivity. Yung 15% na yon is still allowable. Kasi, lalo na kung ang sakit na African Swine Fever is notifiable and it's very communicable dito sa ating bansa, endemic na halos, ay it's better to have false positives than false negatives. Ibig sabihin nun, kahit halimbawa na nagsisimula pa lang at halimbawa ay false positive yon, mas maganda yon over false negative kasi mitigation solutions can immediately be done in the area, knowing that ASF is very communicable. And then, is there a vaccine for ASF? Until now, wala pa. Is there a treatment? Wala pa rin.
Okay. Okay, maraming salamat po, Dr. Domingo. Sana po ay nasagot po ang katanungan ni Ms. Bel Sorara. So, ang susunod pong tanong ay para naman po kay Dr. Mapera. Is the technology for salted egg already available? Where can we avail of the technology?
Okay, so the technology for extending the shelf life of salted egg is already available at the Institute of Food Science and Technology. Later on, you will see my contact details, my email address, and you can just contact us so you can avail of such technology.
Okay. Maraming salamat po, Dr. Mapera. Ngayon po ay balik po ulit tayo kay Dr. Domingo. Ang tanong po ay, Ang tanong po ay, is this readily available? Can it be purchased by anyone? And how much is the kit? And how much is the cost per head of hog?
Okay. Is this readily available? Unang-una, it's Filipino-made. So, readily available. As long as the person who would like to order or to buy will give us, kami kasi ang nagmamanufacture, will give us a lead time of 2 weeks. Kasi depende yon kung merong stock ng supplies, consumables, and reagents, then we can manufacture the test kits. Kasi syempre, mas maganda fresh ang test
Yes
kits.
po.
Tapos nun, can it be purchased by anyone? Of course, it can. But of course, halimbawa, kung ang bibili ay hindi naman veterinaryo, walang background sa laboratory, pwede siya as long na yung kami, we will be able to train that person or the farm owner, for instance, kailangan niya ng training. Kasi it's very user-friendly. The test kit is user-friendly kahit wala kang background sa molecular laboratory skills, pwede. Pero dapat ay merong supervision ng vet kasi once na nag-positive, anong gagawin? So dapat merong vet na nakasubaybay habang ginagawa. At how much?
How much po yung cost?
How much? It's 3,500 per kit, but it can test 10 samples. And how much is the cost per head of hog? Now, ang isang finisher hog or market hog, yung kanyang farm gate price is around 20,000 to 23,500. Kasi tumaas na ngayon dahil kakaunti na lang yung baboy, maraming namatay na baboy dahil sa ASF. So, kung meron kang test kit,
somehow it will help mitigate yung yung pagkalat ng infection na ito, at you can save that cost if you have the if you have the chance to be tested, your pigs are tested with this test kit. Thank you.
Okay. Thank you po, Dr. Domingo. So, dun po sa interesadong bumili ng NanoGold test kit for ASF virus, ang isang test kit po ay nagkahalaga ng 3,500. So, good na po siya for 10 samples. At ito po ay readily available na po, care of Dr. Domingo. So, may isa pa pong tanong. Ngayon naman ay sasagutin natin ating mga resource person ang mga tanong galing sa Facebook Live. Ang unang katanungan po ay, ayan, mula po kay Miss Melly Tenorio ng Eagle Broadcasting Corporation. Ano po ang dahilan ng pagtuloy ng pagdami ng kaso sa Pinas ng ASF kahit may mga interventions na tulad nitong kit na to? Dr. Domingo?
Okay, unang-una, ang ASF, kahit na meron tayong surveillance na pwedeng gamitin yung kit, for instance, pero it's a human-driven disease. Ibig sabihin nun, ang mga farmers, kapag nakikita na nila na yung katabi nilang farm ay sinuslaughter na, no? Kinakal na or sinestamp out na dahil nag-positive, uunahan na nila at talagang intentionally dadalhin na nila at ititinda na nila yung baboy nila, ilalabas na nila, kakalat na yan. Kaya it's a human-driven disease. So it's a very challenging disease, particularly sa mga bansa na medyo may developing, no, challenged na mga bansa. Yung mga farmers natin ay medyo kailangan talaga, kahit may information, education, may pa-seminar pa, pero dahil kailangan nila ng pera, because of that, talagang pinupuslit nila yung baboy. So it's a human-driven disease. Kailangan talaga ng cooperation ng LGU, from municipal, provincial, up to the national level.
Okay.
Also,
okay pa.
meron pa, dahil nga sa swill
Okay po,
feeding.
sige po.
Oo, swill feeding, tapos yung processed pork products, yan, yung mga longganisa, galing pala sa baboy na may ASF, tapos kinakain natin, tapos nun yung mga tira, pinapakain natin doon sa ating alagang baboy, ay hahawa talaga yan. At syempre yung mga traders, yan. So yan yung dahilan. Human-driven disease talaga.
Okay po. Thank you po, Dr. Domingo. May mga sumunod pong katanungan mula kay Eric Aldwin Suarez. Nalaga na po ba ang itlog bago ilagyan ng coating? Kung kukulayan po ba, kakapit pa ng pangkulay? Mukhang kay Dr. Mopera po ito. Kaya Dr. Mopera.
Yes po, kailangan po nating ilaga muna bago ilagay yung coating. So, kakapit naman po yung pangkulay kasi water-based po yung ating coating. Intentional po yon kasi alam po natin na yung ating mga processors, kailangan po nila ng at least markahan yung kanilang mga itlog na maalat. Kaya po, pwede po yan. Huwag po kalimutang ilaga, otherwise, pangit po yung magiging resulta.
Ayun po, okay. Maraming salamat po, Dr. Mopera. So, meron pa pong isang tanong ulit po para po sa inyo. Mula kay Mr. Albert Buen Consejo Belches. Can we still consider the salted eggs cured with cassava starch mixed organic?
Sir, actually, hindi po cured with cassava starch yung aming teknolohiya. Ang pinag-cure pa rin po natin, yung traditional po ninyong brine at saka yung traditional na pag-cure po ng salted duck eggs. Yung pong aming teknolohiya ay pagkatapos po ninyong i-cure yung salted duck egg, tsaka po nyo lalagyan ng cassava starch coating. Is it organic? I consider it as organic. Kasi po, unang-una yung mga materials po na ginamit namin, cassava, ay depende na po yun sa source actually ng pagkukuhanan ninyo. pero halos lahat po ay GRAS, acceptable po. Food safety and quality po ang kinonsider dun sa technology. Yun po.
Okay po. Thank you very much, Dr. Moera. And another question po from Sir Oscar Arredondo Robles. Is there any change in flavor when using coat solution in salted egg?
Okay, so definitely there will be no change in the flavor or the textural property of your egg. Remember, this is just to protect, okay, the eggshell after brining or curing para po hindi mabilis mag-deteriorate yung quality at safety po ng ating itlog na maalat.
Okay. Sige po. Ito pa po, may isa pa pong tanong from Miss Mariflor Abueva Balabat. Ano po ang shelf life ng duck eggs na nailagay sa refrigerator?
Okay, so kung pinag-usapan po natin dito ay yung traditional way, okay, na salted duck eggs, maaari pong mag-extend hanggang isang buwan. Bakit po isang buwan lang sinasabi ko? Kasi po kapag po nilagay natin sa ref, wala pong coating, mas mabilis po ang moisture loss. Tapos ang nangyayari po, pag binuksan yung itlog nyo, magtataka kayo, bakit napakaalat na, tapos ang pangit na nung texture ng ating itlog na maalat. Yung po, kaya po aming ini-extend yung shelf life, tapos ina-address namin yung moisture loss kasi para po sa sensory at saka yung textural properties po ng egg ay na-improve po natin. So generally po, 1 month lang po yung shelf life. Kasi po, sa ambient po yon, kahit po ilagay ninyo sa ref, ganun pa rin po kasi naapektuhan naman po yung sensorial property po ng itlog.
Okay, so may isa pa pong tanong. Where can we buy potassium sorbate and glycerol? From Miss Beth Katz.
Okay, so ito pong mga ingredient na ito ay readily available po sa mga, kahit po sa Divisoria, may mabibilang po kayo nito. At sa Binondo po, may mga reputable suppliers, Allison or HiQ. Doon po sa mga nagtitinda po ng mga food ingredients, mabilis po nating mabibili ito mga raw materials na to.
Okay po. So, ayun po mga tanong. Maraming salamat sa inyo, Dr. Domingo at Dr. Mopera. At para po sa mga nais pa pong magtanong sa ating mga speakers, maaari niyo po silang i-contact sa mga email address na makikita sa ating screen. Ngayon naman ay tatalahayin natin ang seaweed farming mula sa ating susunod na tagapagsalita. Ang ating susunod na tagapagsalita ay si Professor Floridel Dangan Galon, Associate Professor 5 ng College of Sciences, Palawan State University, Tinigiban, Puerto Princesa City. Kasalukuyan din na hinahawakan niya ang Marine Science Laboratory ng PSU kung saan ipinapatupad nito ang mga proyekto tungkol sa seaweed. Pakinggan po natin si Professor Galon sa kanyang presentation.
A pleasant morning to everyone. In behalf of Palawan State University, I shall be presenting the project Pangtawid Program for Coastal Communities of Palawan affected by Luzon lockdown through seaweeds farming. I am Floridel Dangan-Galon, Associate Professor at the College of Sciences, Palawan State University. Let me start by stating that seaweeds are top export aquaculture commodity of the Philippines with an annual production of 1.5 million metric tons. Currency earning from road-dried seaweeds and carrageenan is estimated at 80 billion pesos. During this time of pandemic, particularly when entire Luzon was placed under enhanced community quarantine, seaweed industry of the country had suffered. For one, farming activities were restricted, local and national prices of road-dried seaweeds had declined, and global demand for carrageenan was limited. All key players of the industry were affected, and seaweed farmers of Palawan, the top seaweed producing province in the country, was not an exemption. This Pangtawid program aims to provide livelihood assistance to seaweed farmers of Palawan through establishment of seaweed nurseries utilizing pre-selected fast-growing cultivars from culture facilities of the university. These facilities were constructed from our previous project, supported also by DOST-PCAARRD, the branch and spurculture technology to enhance seaweed production in farms implemented with the University of the Philippines Marine Science Institute in 2012-2014. The specific objectives of this project are the following: to establish 1 hectare of seaweed nursery using pre-selected fast-growing cultivars in the municipalities of Batarasa, Nara, and Dumaran, Palawan; to determine the growth performance of these cultivars in established nurseries; to capacitate seaweed farmers on the initiation of community-based enterprise; and to monitor nurseries production on per cropping cycle vis-a-vis the farmer's income from farming. This Pangtawid program employed the developed frameworks by the university from its seaweed-related activities towards a sustainable seaweed farming system in Palawan. This framework, for instance, promotes the use of pre-selected, fast-growing cultivars from culture facilities for sea-out planting in farms and later on for dispersal to farmers. These also include capability building on emerging seaweed farming technologies and the initiation of community-based enterprise among seaweed farmers associations in Palawan. Culture facilities of the university currently houses nearly 20 different morphotypes or cultivars. 11 cultivars were pre-selected as fast-growing with daily growth rates of 3 to 7%. This figure is relatively higher compared to only 2.5% daily growth rate of most seaweeds from farms. In particular, these include 4 cultivars of Capapicus alvarezi, popularly known as the tambalang, 2 cultivars of Capapicus striatus or the sakul, and about 5 cultivars of Eucuma denticulatum or the spinosum. Another framework used in this study is the modular schematic seaweed farming technique. This framework allows for the expansion of 1 hectare seaweed farm in 6 months' time using only 300 kilograms starter seed stocks. This addresses one of the recurring problems in seaweed farming, which is the limitation on availability of quality seedlings from culture laboratories and in farms. A prerequisite to establishment of this farm is the 10-meter by 10-meter experimental plot where strain selection of cultivars with high growth and survival rates are being performed. Cultivars with relatively high growth and survival rates are being recommended for mass propagations in farm. Seaweed Farmers Association selected as beneficiaries of this project are the Kabuhayan Fisherfolk Association in Dumaran, the Paho Fisherfolk Association in Sarong, Batarasa, and the Kagisan Seaweed Planters Association in Nara, Palawan. These sites were selected to complement the ongoing similar activities of the university and on the basis of full support from the local government units and the willingness of Seaweed Farmers Association to be the project beneficiaries. What we have done so far. Project implementation commenced with project briefing with local government units and target project beneficiaries. One of the highlights of this activity was the discussion of tripartite agreement among PSU, the LGUs, and seaweed farmers associations. Partnership agreements are one of the expected outcomes of the project. This was followed by the establishment of farm modules in the three municipalities with our project beneficiaries. Then the measurement of seaweed growth rate and some environmental parameters in farms. This activity will determine factors that influence spatiotemporal variability on farm productivity, which is a vital input to seaweed agronomy. Early this month, we also conducted the capability building on initiation of community-based enterprise with Paho Fisher Folk Association in Batarasa, Palawan. The same activity was conducted with the Kagisan Seaweed Planters Association in Nara, Palawan. Topics presented were the following: entrepreneurial mindsetting, product branding, organization and management, cooperative management and governance, and basic budgeting and accounting. In the coming days, we shall be facilitating the expansion of their plots into a hectare seaweed farm, monitoring of seaweed growth and farm production. You might be asking how farmers will benefit from this intervention. Presented here is the projected gross income from one unit module measuring 1,000 square meter on per cropping basis. That is at 10,800 per hectare per cropping with the following consideration. Daily growth rate of the seedling is at 4%, and the wet dry ratio is at 8:1, and the price of the dried seaweed is at 60 pesos per kilo. A hectare or 10 units module with 5 cropping cycles will then yield about 540,000 pesos. In terms of projected net income, less 47,166 pesos for farm input and labor, that is at 60,834 per hectare per cropping. Such income can further be increased up to 88,000 per hectare per cropping on the succeeding years when farm input and labor is reduced to 20,000 pesos. These figures are relatively higher compared to only 20,334 pesos net income per hectare per cropping if one will use seedlings with only 2.5% daily growth rate. Indeed, seaweed farming is a lucrative livelihood. The challenge to us now is how to make it more sustainable. What I just presented is an initial attempt to shift the paradigm, to move one step at a time from the traditional practices on seaweed farming, characterized by the use of old planting material, insufficient financial support for farm materials, and dole out government funding, towards promising approaches and tools in seaweed farming, such as the use of pre-selected fast-growing cultivars, sufficient financial support to our farmers through establishment of seaweed nurseries, and the initiation of community-based enterprise among seaweed farmers associations. For me, no matter how simple these initiatives are, still, this is science for the people. Thank you and good morning once again.
Yan, maraming salamat po, Professor Galon. I-remind lang po namin ang ating mga viewers na maaari kayong mag-comment ng inyong mga katanungan sa comment section dito sa ating live streaming. Ang susunod na open forum ay magaganap pagkatapos ng dalawang topic, kaya't manatiling manood ng aming live webinar. Hinihikayat muli namin na i-share po ang ating live webinar sa ating mga FB wall upang marami pa po ang makapanood at makalahok sa ating talakayan ngayong umaga. Ang susunod na paksa ay tungkol sa textile industry na tatalakayin ni Ms. Jenny Lee E. Kaya. Si Ms. Jenny Lee E. Kaya ay Senior Science Research Specialist ng Natural Fiber Utilization Section ng Research and Development Division ng DOST Philippine Textile Research Institute o PTRI. Hindi ko na po papatagalin at alam ko pong excited na ang ating mga viewers, kaya pakinggan natin si Ms. Kaya sa kanyang presentation.
Hi, a pleasant morning to all of you. Today, allow me to present our work with BANDALA, a new fiber we use for textile production. First, let me tell you a little something about the Philippine Textile Research Institute. We are the premier research and development institution, or RDI, mandated to conduct research and development for the textile and allied sectors. Our mission to support the Philippine textile, garment, and allied micro, small, and medium-sized enterprises achieve global competitiveness with unwavering commitment to work with excellence and integrity through judicious utilization of textile-based resources, development and transfer of innovative technologies, enhancement of human resource capabilities, and promotion of quality assurance and quality control. Natural textile fiber is one of the textile-based resources that has been utilized extensively by the DOST PTRI in the conduct of its research and development. Through its natural fiber utilization section of its Research and Development Division, it has profiled and studied more than 20 natural fibers from different plant sources for textile applications. These include leaf fibers such as pineapple, maguey, yucca, banana, and abaca, bast fibers such as rami, jute or saluyot, and kenna, and fruit fibers such as cocoa coir and kapok. Our study also derived textile fibers from bamboo and sugarcane bagasse. One of the Institute's driving force for our continuous studies in the use of natural fibers for textile is the fact that the international textile industry is one of major contributors to global environmental pollution. In 2015, the industry was responsible for the consumption of 79 billion cubic meters of water, which translates to roughly 31 million Olympic-sized swimming pools. The textile industry also generated 1.7 million tons of carbon dioxide emissions, or an equivalent to 370,000 passenger cars running 50 kilometers per day for a whole year. Concern is also growing with some of the recent studies showing that clothes shed large amounts of fibers, some of which enter the aquatic systems and may pose threats to aquatic life. It is estimated that one washload of polyester clothes sends up to 700,000 microplastics back to the environment. In response to changes in public attitude towards plastic microfibers, natural textile fibers are gaining more and more interest from the manufacturing perspective, rallying behind labels such as eco-fashion and sustainable fashion. This has now become a big, booming business that is no longer limited to niche designers. Sustainable materials are now making their way into boardrooms and onto catwalks. Just as eating organic went from niche market to expansive trend, sustainable fashion is becoming more readily available and affordable. In 2015, the DOST PTRI was invited to join the R&D program on abaca fiber for specialty papers, textile, and other high-end products. You may or may not be aware that we export 75% of abaca's pulp valued at around 150 pesos per kilogram. While this industry has helped our abaca farmers and has continued to regional economic development, it has put limitation on our ability to convert this natural resource into higher valued products. Through the program, the downstream conversion of the abaca fiber was explored, including that of textiles. Why is value transformation important? Further product conversion within the country means building an industry that can provide jobs to its population and more income opportunities for its people. A spinnable abaca fiber can be valued by as much as 900 pesos per kilogram, which is 9 times the abaca fiber cost. Since this particular technology is community deployable, it offers a potential for regional industry development and livelihood opportunities to the abaca fiber producers and other stakeholders. The DOST-PTRI already has an existing technology in the conversion of abaca fiber into textiles. This patented technology centers in the process of developing a spinnable fiber form which is ready for yarn production. In blend with other commercially available fibers such as cotton and lyocell, it is applicable in known spinning systems such as the short or the cotton spinning system and the long staple or the semi-worsted spinning system. This spinning system converts fibers into yarns and require fiber with processable properties. The yarns developed and or produced are then woven or knitted to come up with the fabrics. An overview of these technologies is provided in the given slide. Existing systems are already in place in terms of the collection and extraction of abaca fibers from the plant pseudostems. The technology of PTRI is in the fiber treatment and its subsequent mechanical preparation. It is formulated knowing that natural fiber is composed of lignin, hemicelluloses, pectin, waxy materials, and natural oils, which cover the outside layer of the fiber's cell wall. The treatment is used to alter the structure of the cellulose in the plant fibers by cleaning the surface off of these compounds. Cellulose is known as the textile polymer, and as reference, cotton is about 95% cellulose. The treatment ultimately increases the cellulose content of the fiber material while retaining some of its mechanical integrity, needed for further spinning and subsequent weaving and or spinning. The project adopted this technology to a new Musa variety developed by the University of the Philippines Los Baños Institute of Plant Breeding, BANDALA. BANDALA is a backcross between bunchy-top virus-susceptible abaca with a wild native banana variety Pacol resistant to the said virus. Bunchy-top virus is known as the most destructive disease of the industry. Last year, Catanduanes, the top abaca fiber producer, which accounts for 35% of the country's total production, suffered almost $500 million loss due to the virus. It has affected about 20% of its total plantation area. This is on top of the devastation suffered by other provinces which entirely wiped out its abaca plantation, including Laguna, Cavite, Surigao, and Davao Oriental, since its discovery in 1916. The UPLB-IPB has successfully developed a Musa variety which is bunchy-top virus resistant. It has undergone several field trials and has proven its resistance in different geographical locations across the Philippines. The total fiber yield per hectare was much higher when compared to abaca, which has very low tolerance to the said virus, and resulted to very low fiber yield amidst infection. Bandala is actually shorter term to the new variety's description, which is backcross abaca to native with desirable accessions to lift up the abaca industry. The following slides will discuss the study conducted on the new Musa variety as a raw material for textile manufacturing. As raw and treated fibers, Bandala was subjected to mechanical tests. The breaking load on the tensile direction was determined using a universal testing machine. From the given graph and when compared to abaca fiber, Bandala fiber has lower breaking load in both raw and treated fiber samples. Fiber fineness was also determined. The unit used is denier, which is correlated to the weight of the fiber for every 9,000 meters. The lower the number, the finer it is. And for reference, silk filament weighs about 1 gram per 9,000 meters. From the finest graph, you can see that bandala is 3 times finer than abaca in raw fiber form and 2 times finer when treated. In textile manufacturing, fiber fineness is considered one of the most important textile fiber properties, and finer fibers are generally preferred. Finer fiber has better spinnability performance, better dye uptake, more lustrous, and has better fabric drape and uniformity. Tenacity is the measure of relative fiber strength, which considers fineness as a factor of strength. The graph shown indicates that when fineness is taken into the context of strength, the difference of values obtained between bandala and abaca fiber is significantly reduced. Earlier, it was mentioned that lignins, hemicelluloses, pectins, and other wax and oils make up the outer layer of the fiber's cell wall. These compounds cumulatively is represented by gum content. It was referred to as gums because these compounds cement or glue the fibrils or individual fibers together. After treatment, gums must significantly be removed, and cellulose, which are basically longer chain of glucose and has segment of crystalline structure, known resilient to alkaline treatment condition, remains. To determine the effect of the treatment process to the fiber's composition, percent total cellulose and percent residual gum content were determined. From the given graph, it can be seen that after treatment, percent residual gum content for bandala and abaca fibers decreased and cellulose content increased. SEM images of the bandala and abaca fibers were also obtained. It can be observed that treated bandala and abaca fibers have cleaner fiber surface than the raw fibers. This suggests that treatment applied was successful in removing the non-cellulosic components from the fiber surface. Treated fibers are opened and blended prior to spinning into yarns. Blended material containing 75% cotton and 25% bandala or abaca was prepared. The yarns were then characterized in terms of the physical and mechanical properties. Breaking strength and percent elongation at break are higher in abaca blended yarn, while yarn number is higher in bandala. Yarn number is a measure of yarn coarseness or fineness. Lower number means coarser yarn and higher number finer yarns. Because bandala fiber is finer, the resultant yarns were also finer. During spinning, cohesion of the blended fiber material is determined through percent fiber composition and number of twists in the yarns. The interfiber cohesion is an important aspect to be considered since it is directly related to the twist and indirectly affects the productivity in yarn spinning. Fibers with better cohesion produce yarns at lower twist number, and the composition of blended yarns is closest to the blending ratio. From the given result, bandala blended yarns has yarn fiber composition closer to the blending ratio and lowest twist number, which suggests better cohesion between and among the fibers in the blended material. It has also been reported that finer fibers has better spinning cohesion than coarser fibers. Bandala, when compared to abaca, has finer fiber that can be attributed to its better cohesion property. From the results presented, the study was able to identify and prove that bandala fiber as a new musa variety is a new natural fiber for textile production. Yarns produced from the study were further converted into knitted and woven fabrics. Prototype apparels and PPEs were also developed. The fabrics were naturally dyed using annatto seeds or atsuete and indigo leaves, thereby creating a 100% Philippine textile product that embodies the soil to near skin material conversion. The study supports and advocates an integrated textile value chain in regional or localized setting by harnessing the natural resources available in the country and supporting the propagation of new and verified textile fiber crops. Through this regional approach, livelihood opportunities are being opened, income generation remains with the countryside, and more Filipinos can benefit from the natural resources and the rich biodiversity of our land. It is time that we say that Philippine fiber is for Philippine textiles. and let our farmers, our weavers, our fashion designers, and garment manufacturers work on textiles truly and proudly made in the Philippines. In the next coming years, you will not only see these natural textile fibers, including bandala, as wearables, but also as non-woven material that has more industrial application for home, for medical use, construction, and even agriculture. And we are excited to share with you our developments and updates regarding the non-woven program in the next coming months. If you are interested to know more about the DOST-PTRI and the current R&D thrusts of our agency, please follow us in our official social media accounts or contact us through the details shown on the screen. Thank you.
Maraming salamat sa inyo, Miss Kaya. Talaga namang malaki ang may tutulong ng bandala fibers sa textile industry ng ating bansa. Ang huli nating paksa o topic ay tungkol sa urban gardening. Alam ko madami sa inyo ang nakahihiligan ang pagtatanim, lalo na ng mga ornamental plants. Upang talakayin ito, narito si Dr. Eduardo P. Paningbatan Jr., isang seasoned soil science specialist, at siya ay retirado ng professor ng University of the Philippines, Los Baños. Ngayon, upang bigyan tayo ng detalye tungkol sa EPP, narito si Dr. Eduardo P. Paningbatan Jr. Trivia lang po, ang EPP technology ay abbreviation ng pangalan ni Dr. Eduardo na siya ring EPP. Kaya let us all welcome Dr. EPP.
Good morning. First of all, I would like to thank Picard for giving me this opportunity to discuss and present a technology on urban gardening that I developed some 15 years ago. It's Picard who first convinced me to extend this to rural and urban communities. And this technology is what we call EPP technology. What is EPP? Practically, EPP is a potting preparation. It's called super paso for growing vegetables and herbs having three interrelated components. And these are the potting medium, a fertilizer which is called compost soil extract, which contain all the essential plant nutrient elements, and the container of the vessel, which is actually made out of recycled plastic material with holes to enhance soil aeration, capable of automatic ferti-irrigation. This container garden system that is appropriate for urban agriculture. It is organic based. It is pesticides free. We can cultivate a lot of potted plants using this vertical expansion of planting. And this is good for limited backyard space. It is portable. You can transfer the plant in any place where it can receive sunlight, or you can even grow it near your kitchen. There are a variety of vegetables and herbs that can be easily cared. One feature of this container gardening system is that you can do continued harvesting of fresh vegetables, and it can provide a better protection against pests, strong rain, and typhoon. It provides better control of the factors of growth, thus easier to enhance or improve crop productivity. And of course, it is environment friendly. It uses recycled materials. EPP, or Enriched Potting Preparation, is designed to provide plant needs in terms of sufficient amount and balanced proportion of water, air, and nutrients. These are the 16 essential nutrient elements that is provided in this super paso technology. These are the macronutrients. The technology also provides these micronutrient elements. So these are the components of EPP. We have this potting medium, which is organic, and we have also a liquid fertilizer which is called compost soil extract that is enriched with plant nutrient elements. And of course, we have the paso itself, the container, which is made up of recycled materials. I also did a lot of gadgets to improve watering system and to improve aeration and fertilization of this urban gardening system. So these are my first plant that was taken some 13 years ago. When I developed this technology, it's only for myself, no? Because I was sick, and the doctor said that I can easily get well if I eat more and more vegetables and fruits. So this is the procedure of this technology, procedure of seed planting and transplanting the seedlings. We grow our seedlings right there in the super paso. That's how we transplant the seedlings, how we water the seedlings just by dripping it with drops of water. And we cover the newly planted seedlings for complete protection, no? Against pests, occurrence of pests, against impact of drops of water. No? So this is a complete protection of the seedlings. That's why almost 100% guarantee of success that you can grow your vegetables in this kind of technology. And we water initially the plants, no, by dipping it in water. And of course, when we dip it in water and lift it up, all the excess water will be removed, will drip out, and air will come in. So you have a soil or a medium that is almost contains sufficient amount of air and water. And we hang the plant to receive at least 2 hours of sunshine. It would be better if it's more than 2 hours of photosynthetic activity. And these are your growing plants. This is mustard, so we can water them with ilagadera. And that is lechugas, mayroon diyang basil, and the sili. And this is how we control pests and diseases. If there are only 1 or 2 pests in your plants, then you can terricide, no, with your fingers. But if there are a lot of, let's say, aphids or scale insect, we have this drowning technique. You can submerge the whole plant in a pail of water for 10 to 20 minutes. Of course, we should not use pesticides. Many vegetables and herbs can be grown in this technology, the APP way, no? Vegetables like lechugas, pichay mustasa, tomato, eggplant, ampalaya, okra, ginger, beans, kangkong, hot pepper, sweet pepper, kale, saluyot, kamote, taps, and of course for the herbs. I usually also grow the herbs, no? If you sell the herbs, the command better price than the vegetables, no? Like basil, mint, parsley, sage, rosemary, thyme, once caper, lime, tarragon, stevia, gotocola, oregano, gainor, and many, many more. And these are some of my super paso plants, no? And that is gotocola. And that is basil, no? Basil. Masarap yung basil. And that's pak choy. Lechugas. We have this super plant called kale that can be easily grown in this technology. We have the mustard. We can easily grow upland kangkong. Actually, I developed an aquaponic systems wherein I can grow easily upland or kangkong. No, what's good about this kangkong is that you just cut it, and then in about 7 to 10 days, it will sprout and look like the original plant. No, and that one is lechugas. We can also grow bell pepper, hot pepper, mint, oregano. This is the gynora. This gynora is an anti-cholesterol plant. The scientific name is Gynora nepalensis. And of course, you can grow rosemary, spring onion. We have this ampalaya, and we can even grow this cucumber, no? Hot chili, upland kangkong. And this is how we exhibit. I participate in some exhibits, and we have this kind of exhibits. This is my backyard, no? These are hanging garden, no? This is vertical gardening. You can grow eggplant, then we have that pepper, and then you have this tomato down below. And that is also the house of my neighbor. And you can see that we can grow lot of vegetables in fences. This is cherry tomatoes. Gabi is good for a shaded area. And that is another variety of lechugas. That's hot pepper. Even ornamental plants, you can grow this in Super Paso. Another exhibit, no, look at the cherry tomatoes, pahaba ng pabaha. Cherry tomatoes is an indeterminate plant. That's my backyard. Really, this technology is for urban gardening. I have an interlink fence. I grow them in my fences. Oh, this is a technology that I also developed. This is aquaponics. This could be considered as the cheapest aquaponics in the world, because it does not require electricity or aerator. And look at the pichay and some celery. They are growing very well in this technology. Look at the plant roots. Half drum contains 10 to 12 red tilapia. That is my version now, or my that I develop. That is a kangkong. Actually, this is an aquaponics and hydroponics combined using this EPP technology. That's my tower garden. That's lechugas, mayroong gotokola, and other you can grow almost any herbs and vegetables in this tower garden. It also have this watering system. You can automatically water your system. In this case, I developed the what I call patak irrigation system. That's my vertical stand garden. No, you can grow lechugas, mayroong kamote, and almost all the super paso plants that I presented can be grown in this kind of setup. Oh, this is, I also have I develop a what I call salad garden by the sea. Yeah, it's terrific, and you can eat your salad right there besides the sea. And that is a rooftop garden that now I am developing. This crop of vegetables, and this system I call it as coconut greenhouse with the super paso plants. No, fortunately, nagdaan yung typhoon, especially Ulysses, ay hindi na-apektuhan yung aking plant. This is after Ulysses, no? What's good thing about this coconut is that it can minimize pests and pest attack, no? And you can actually remove the remove the top portion of the greenhouse, the coconut, and to expose the plant for full sunlight. And so this is our technology that right now we are disseminating, especially in urban areas. In Metro Manila, we have this project with DOST, the National Capital Region. We are helping several barangays now, and another project is coming out to help more and more urban dwellers, particularly during this COVID period crisis. And they can grow their own vegetable in Paso, in Super Paso. And this is the technology that I have. And the technology is most appropriate, of course, for urban communities. For calamity-stricken areas, I've been to during the typhoons, the Lahar flow in Albay, in Infanta, I was also there, and this is good for rehabilitation centers. No, EPP is now being promoted in Metro Manila. No, and of course it's for better nutrition. Particularly in for the urban poor, magandang pang-boss ng immune system, and actually you can also generate income. I am now processing a system wherein I can grow 1,000 pots and it can give a very good income for the practitioner, for the gardener. Maraming salamat po.
Maraming salamat po muli, Dr. Paning Batan. Marami ang matutulungan ng inyong EPP technology na siyang kapaki-pakinabang sa mga nag-aalaga ng halaman o di kaya ng mga pananim na gulay. Hinihikayat ko po muli ang ating mga viewers na i-share ang ating webinar upang mas marami pa ang makalahok at makasama sa ating talakayan. Ngayon po ay iniimbitahan muli namin sina Professor Galon, Ms. Kaya at Dr. Paning Batan sa screen para sagutin ang ilan sa mga katanungan ng ating audience. Hello po!
Morning.
Ay, morning po. May mga ilang mga tanong lang po tayo na natanggap mula sa ating registrants po. Ang unang tanong po ay para kay Professor Galon. Ang tanong po ay mula kay Von Perez at saka kay Sir Rafi Rico ng Noonbreak Balita. How was seaweed farming affected by the pandemic? Paano rin po naaapektuhan ang ating mga kababayang dinaanan ng nakaraang bagyo?
Good morning once again. As mentioned in my presentation, not only our seaweed farmers were affected by the pandemic, but the entire seaweed industry of the country. Number one po dyan, farming activities were restricted. The market price of the product of our farmers, the road-dried seaweed, had declined, and global demand for carrageenan was limited. Carrageenan or semi-refined carrageenan is the export product that we derive from road-dried seaweeds produced by our farmers. Thank you.
Okay, maraming salamat po, Professor Galon. Ang susunod po na ating katanungan ay mula kay Ms. Melly Tenorio ng Eagle Broadcasting Corporation. Ang kanyang tanong po ay, what are the advantages of BANDALA fibers over the other native fibers in the land? Ms. Kaya?
Yes, hello, good morning once again. So as mentioned in my presentation, particularly for textile manufacturing, is the fiber fineness. Because in textile manufacturing, fiber fineness has a list of advantages. So not only in terms of the yarns that you can develop, but in terms of the fabric that you can produce out of it. But of course, as mentioned, the bandala is also resistant to abaca bunchy top. So not only that you will get really nice fabrics out of it, you can also get high productivity in terms of propagation.
Okay. Maraming salamat po sa pagsagot, Ms. Kaya. Ang susunod po nating katanungan ay mula kay Mr. John Kenneth M. Julian from LSPU. Ang tanong po ay para kay Dr. Paning Batan. Ano ang gamit ng vermicast at carbonized rice hull?
Ang vermicast ay isang sangkap ng yung ating organic potting mix. At napakahalaga ho yan kasi yan, ang vermicast ay fully decomposed na organic matter. Ang carbonized rice hull, isa ring component yan. Actually, ito yung tinatawag namin ipangsunog. No? Ipangsunog. Nilalahukan ko ng ipangsunog ang ating organic potting medium kasi ang ipangsunog ay mataas ang potassium. Alam ho ninyo yung word potas ay galing sa pat at saka as, kaya potas. No? Kaya lahat ng mga abo ay mataas ang potassium. Ginagamit ko rin yung ipangsunog kasi pagka nag-grow ka ng vegetables sa isang paso, ay kuminsan ay mayroong mga earthworms na kumakain ng ugat ng mga halaman. At pagka nilahukan mo ng ipangsunog, ayaw na ayaw ng mga earthworm. Of course, ang earthworm napakahalaga during the decomposition process, no? Sa paggagawa ng ating vermicast.
Okay. Ayun po. So, maraming salamat po sa pagsagot ng katanungan, Professor Paning Batan. Ang susunod po na tanong ay mula naman po kay Mr. Joseph Paul M. Velez ng Ifugao State University. Para po ito kay Professor Galon. What are other programs that can be implemented for the affected constituents in line with seaweed production?
Thank you for that question. From my perspective, on top of the ongoing initiatives presented in my presentation, I think another program that can be implemented is linking our seaweed farmers to microfinancing agencies so that they can avail of seed capital to start with their community-based enterprise and to likewise link or directly link them to the seaweed processing processors so that they can get value from their product. Um, yes, so that's also one way to streamline the traders in our seaweed value chain. Thank you.
Okay po, thank you Professor Galon. Ang sumunod naman po na tanong ay para kay Miss Kaya. Mula po kay Mr. Manolito C. Liwanag ng Diaryo Pilipinas. Ang tanong niya po ay, kamusta na po ang lagay ng textile fiber industry sa bansa? Ay, ma'am.
Hello
Ayan
again,
po.
good morning. Yes. So that's a very loaded question, no? Because we know if we talk about how is the textile industry in the Philippines, there are so many factors that you need to consider.
Yes.
So to be really honest about it, we have like literally a handful of textile mills in the country. So in terms of their economic contribution, if they are so few, then we know that their impact or their economic impact in our country maybe not that sizable. But of course, our garments, when we talk about the garments, we have so many garment industry in the country, and they provide a lot of jobs to our people. But on another side or another end, we have a lot of countryside textile operators, our handloom weaving industry. But the gap is that we don't have statistics, how many they are, what is their productivity. So I guess to fully answer that question, we need all those data present. We need all this data collected so that we can say that these handloom weaving communities, they can contribute not just to the regional development or economic development, but in terms of national development.
Okay, thank you Miss Kaya sa pagsagot ng tanong. Ang sumunod na po na katanungan ay para kay Dr. Paning Batan mula kay Miss Carissa Cave G. Viloria. Ang kanyang tanong ay, what are the ingredients that are not recommended to use in mixing with their potting medium?
Yung katanungan ay napakaraming ingredients na hindi pwedeng ilahok. But sa tingin ko, ang gusto siguro itanong ay ano ba talaga ang magagandang ingredients na nasa potting mix natin. Ang wag na wag nating ilagay ay yung hindi na-decompose. Halimbawa,
Mhm.
mga manures, no? Chicken or carabao manures, actually, it has to be fully decomposed first before it can be mixed in our potting medium, no? Mga plant leaves, huwag kayong maglalagay ng yung mga crop residues na hindi fully decomposed, no? Ganyan ho, ang requirement, yung organic potting mix, ang lahat ay dapat fully decomposed. Alam natin, ang decomposition ay napakahalaga ang role ng microorganisms. At saka ang microorganisms need time to decompose itong mga organic residues katulad ng mga rice hay, mga manures, and the likes.
Okay po. Thank you very much po, Dr. Paning Batan, sa pagsagot ng tanong. Ang sumunod na ba pong tanong ay para kay Professor Galon from ito po. What are the effective and sustainable interventions can the government provide to the seaweed farmers considering the problems on transport of the seaweed products to Metro Manila and other areas?
Good morning again. For me, especially when we talk of seaweed farmers or seaweed industry in Palawan, one necessary intervention that the government can explore is the establishment of just even a low-cost processing plant in Palawan, considering Palawan as the top seaweed producing province in the country. That will solve the problems, one of the problems of our seaweed farmers related to unstable or unpredicted market price of road-dried seaweed. Another intervention the government can likewise explore is to start mechanizing the seaweed farm operation in Palawan. That is to support the RDS or road-dried seaweed requirement in case the processing plants are already established in the island province of Palawan. Thank you.
Okay, maraming salamat po, Professor Galon. Ang sumunod naman pong katanungan ay para kay Ms. Kaya from Mr. Rodel G. Maghirang ng IPB. What is the acceptability of BANDALA to abaca markets and traders?
Yes, hello. So I mean, Bandala is not yet commercially propagated. I think everybody knows that. We still need to secure a lot of agreement and clearances now. We are also very excited how the market will perceive it or will accept it. But just siguro as a reference, we already have like the NTF, the one that's made from abaca, from banana, and we have a project, the ready to buy project, and they're moving fairly fast. So I think the reception of the public in terms of the marketability of this natural textile fabrics is very well considered.
Okay. May isa pa pong tanong, Ms. Kaya, para sa inyo po ulit. Does this bandala require the same care and management like those in traditional abaca? From Ms.
Okay.
Arlene L. Aquino from Pibla Elementary School.
That's right. So let me first qualify, no, because we already know that there is an abaca textile that is in South Cotabato. We know them as tinalak, and we know them as dagmay or our sinamay. So these are also considered abaca textiles, and it has a very different form and properties when we compare it to the PTRI developed technology. So the traditional ones, it involves very physical and mechanical conversion, whereas the PTRI's technology, we used, of course, mechano, chemical, and physical transformations. Considering Bandala and Abaca, I mean, considering that they went through the very same process, the care management is fairly the same.
Okay. So the same lang po. Okay, ngayon naman po ay sasagutin ng ating mga resource person ang mga tanong galing sa Facebook Live. Ang unang katanungan ay mula kay Hazel Joy Abundo at Miss Bel Sorara. Marami po talagang product na ngayon na gawa sa seaweeds like seaweed crackers, seaweed pasta, at ginagawa na rin siyang fertilizer. May iba pa po bang bagong products na hango sa seaweeds?
Sa literature po natin marami po, no? But I'm not quite updated po kasi that is part of the value added. Pero it has a lot of industrial and commercial applications. Isama na rin po natin dyan na ginagamit na rin po siya sa pamalit sa kapsula ng ating mga gamot. Yun pong gel.
Hello? Hello? Prof. Galon? Hello?
Yan.
Ayan, hello po. Ayun,
Yan.
sige po. Sige po ma'am, ituloy niyo po kung meron pa po. Okay.
Nasa nanotechnology na rin po. Some other applications of seaweed. Thank you po.
Okay, thank you very much po. Okay, may mga sumunod pa pong tanong mula kay Mr. Mysore Palman Abdul Latif. Regarding po sa salinity ng seaweeds, ano po yung optimum, I think, range na mabilis lumaki ang seaweed?
Since ang seaweeds po natin ay marine plant, like, actually hindi po talaga siya marine, no? Meron pang tubig kasi as of now po nasa kingdom proteus pa rin sila. Marine organism po siya. So, ang kailangan niya po na salinity ay 35 parts per thousand. No, yun po yung ideal. And I think that's also the optimum. But that could play around 33 to 36 parts per thousand. Thank you.
Okay, thank you, Prof. Galon. Meron naman po sumunod para naman po kay Miss Kaya. Mula kay Miss Glisa, si Agtuno. Meron po bang future plans to partner with luxury brands of the Philippines?
Regarding partnering with luxury brands, no? So I think we can now move a little bit away from BANDALA or the natural textile fiber because it is an encompassing, I think, direction. So not only very, very particularly about BANDALA or abaca, we also have our silk, ano? And so I think it is very promising. The challenge is, I think, for our stakeholders, our industry, to actually make this happen. And PTR is just here to provide the technologies needed. I think the positive side of having our natural fibers gathered here in the Philippines is that this is a value addition. This is something that we can say that can be Philippine sourced. And I think that is important. If you talk about luxury, you need an identifying feature. And our natural fiber can be our identifying feature so that we can compete with luxury brands.
Yes, that's right po, Miss Kaya. May isa pa pong tanong. Mula po kay Miss Melly Tenorio. Walang effect ang plastic container sa mga halaman na nakatanim dito. I think para po ito kay Dr. Paning Batan.
Wala naman, no? Kasi alam niyo yung plastic container na ginagamit natin ay very stable ho yan. In fact, ang plastic container ay mayroong advantage. Yung plastic container na ginagamit ko ay magagamit mo sa loob ng, yung aking ma-experience ay mahigit na 10 taon, no? Hindi katulad mga commercial available na plastic container, 1 taon nagiging brittle na yan at saka na it becomes magiging pollutant. Pero kung ang ating plastic container na ito ay may i-reuse natin, may i-recycle natin, then we are actually helping the environment. Nabawasan natin yung carbon footprint ika.
Yes,
no? So, napakahalagang intindihan.
Okay po. So, sir, mukhang meron pong tanong po ulit para sa inyo. Mula po kay Miss Ruby Lim. Good morning. Paano po i-prevent yung snails from infesting our plants? Thank you po, Sir EPP.
Yung sa technology ho ng na develop, ito yung nakahang, no? Mahirap puntahan yung mga snails, no? Yung mga snails, yung Japanese snail. Kaya hindi ko gaanong naging problema ang mga snails pagka gumagamit kayo ng EPP technology. Pero kung nandyan yan, ay mahirap talaga i-controlling yan. Ang ginagawa ko rin, naalis ko yung frutas, binabato ko sa ano. Mahirap gumamit ng mga chemicals para makontrol yung snails.
Opo. Yun po. So, meron po ulit katanungan para sa inyo po ulit, Professor EVP. Mula kay Miss Mariflor Abueva, ano po ang mabisang gawin kung ang mga tanim mo ay inatake po ng mga pulang langgam, especially po sa mga okra at talong?
Alam mo rin nyo, ang pagkakaroon ng mga langgam sa ating halaman ay sari yan sa another pest, no? Yung mga aphids kasi, ang aphids produce ng honey, kaya ang langgam, actually hindi yung langgam ang peste. Pinupuntahan niya yung aphids, kinakain yung honey na pinuproduce ng aphids, no? Kaya kung halimbawa, ang langgam din ay siya ang nagkakalat ng aphids, no? Yung aphids na peste sa atin. Paano natin kontrolin, no? Again, pagka yung drowning technique na sinabi ko kanina, ilubog mo lang ay talagang pati yung mga langgam ay mawawala na, no? Madra-drown sila, malulunod, no? Yun ang aking pagkukontrol ng mga langgam, mga aphids, mga peste sa superpaso technology.
Okay po, thank you very much. May last question na po, I think. Ito po ay from Miss Ana Maria Buraga. Tama ba? Can students seek assistance from your office if the fibers they have extracted can be turned into textile? Last semester, they designed a machine that would extract fibers from young coconut. They are trying to look for ways to soften the fibers, but classes were suddenly suspended. I think for Miss Kaya po itong question.
Yes. Yes, we do. We have many programs available for our students now. One is that the joint research undertaking. The joint research undertaking, we actually help our students, and we also polish their experimental design. Now, we are very active in terms of our involvement in the conduct of their R&D. We also have the other one, the open lab agreement, which is, we open our facilities. So if those facilities are not available in their schools and we have it in PTRI, then we open our facilities for them to use. So yes, please contact us. I've provided our contact details and the presentation. I think you also have it on the next episode.
Okay, so yun na po yung mga tanong. So salamat po sa ating mga magagaling na resource person na sina Professor Galon, Ms. Kaya, Dr. Paning Batan, Dr. Domingo, at Dr. Mopera na nagbahagi ng mga impormasyon na makatutulong sa ating mga Pilipino.
Yay!
Okay po. Ayan po. So, para po ulit sa mga nais po magtanong sa ating mga speakers, maaari niyo po silang i-contact sa mga email address na makikita sa ating screen. Yan, nasabi naman namin kanina na magbibigay kami ng e-certificate para sa webinar na ito. Makikita ninyo ang link sa comment section at makikita rin ito sa huling parte ng ating webinar. Pero bago tayo magtapos, magbabahagi ng isang mensahe ang ating OIC Deputy Executive Director for Research and Development, Dr. Juanito T. Batalon.
Magandang umaga sa ating lahat. Ako ay taus-pusong nagpapasalamat sa ating mga tagapanood na tumutok sa ating webinar sa loob ng 2 oras. Salamat sa inyong pagsubaybay at sa inyong pakikinig. Ang inyong mga tanong ay nagpapatunay ng inyong interes sa mga teknolohiya at proyektong ating tinalakay. Nagpapasalamat din ako sa ating mga mahuhusay na tagapagsalita. Sa kabila ng inyong pagiging abala sa inyong mga ginagampanang tungkulin, sa inyong mga ehensya, binigyan ninyo ng oras ang webinar na ito. Salamat sa pagbahagi ng mahahalagang impormasyon sa ating mga kababayan. Para sa ating mga kababayan, maaasahan ninyo na ang mga impormasyon inyong narinig at teknolohiyang inyong natutunan ngayon ay hindi fake news. Ito ay base sa siyensya ng ating mga respetadong faculty researchers. Ang DOST-PCAARRD ay patuloy na magbibigay ng suporta sa mga proyektong makakapagpaangat ng kabuhayan ng komunidad. Patuloy kaming magbibigay ng technical assistance at rekomendasyon at science-based solutions to problems in agriculture, aquatic, and natural resources. Sa mga private sectors at startup companies, small and medium-scale enterprises, nawa ang produkto ng siyensya ay maging kapaki-pakinabang din upang ang aming sektor ay makapag-ambag sa pangkalahatang pag-unlad ng ekonomiya ng ating bansa. Ang pandemyang ating kinakaharap ngayon, ang mga kaliwat-kanang disasters na ating nararanasan, kawalan ng pagkakakitaan at iba pa. Sana ay matiyaga at positibo nating harapin ang pagbangon. Ang minsan ay sulyakin at tutukan ang mga impormasyon at teknolohiyang ambag ng DOST-PCAARRD upang maibsan ang hamon ng pagbangon. Muli, maraming salamat at mabuhay tayong lahat.
Yan, maraming salamat po sa inyo, Dr. Johnny. Upang masiguro na makuha ninyo ang inyong e-certificate, maaari lamang i-fill out ang aming customer satisfaction feedback form na makikita sa comment section at mamaya lalabas sa inyong mga screen. Isasara namin ang pag-fill out nito ng alas 2 ng hapon o 3 oras matapos ang webinar na ito, kaya bisitahin ang link na makikita sa comment section. Maaari nyo makita ang contact details ng ating resource speaker sa inyong screen pagkatapos ng ating webinar. Abangan nyo po ito mamaya ulit. Inaanyayahan din namin kayo na bisitahin ang aming virtual exhibit habang ito ay online pa. Bisitahin ito sa URL na makikita sa inyong mga screen. Meron din kaming QR code na maaari ninyong i-scan. Mag-download lamang ng QR scanner sa inyong mga cellphone at i-scan ang QR code na makikita sa inyong screen. Sa puntong ito ng ating webinar ay nagpapasalamat kami sa mga tagapagsalita at sa inyong lahat sa pagdalo at paglahok sa ating talakayan. Sana ay marami kayong natutunan sa aming webinar na bahagi ng pagdiriwang ng National Science and Technology Week o NSTW. Muli, ako ang inyong host na si Jamsi Perez na bumabati ng magandang umaga at masayang weekend sa ating lahat.